Okay, did you guys get enough food this week so far? Yeah, that's one thing NDC does well, right? Okay, so thanks for coming to my session here on authorization for your web apps and your web APIs. My name is Brock Allen. I guess you'd call me an application security architect. I do consulting and help companies and customers through a company called Alliance. And at Alliance, we have a security practice where we help our customers with their identity management architecture, getting things like single sign-on set up, and protecting web APIs. I also work on something called Identity Server, which is an open source project and framework for helping achieve those architectures. And it helps out with implementing the OpenID Connect and OAuth 2 protocols that you would set up if you're building that kind of architecture. And it's really good about kind of giving you out of the box authentication and protection for your APIs for the most common scenarios. But it's also very, very flexible, such that if you have some odd requirements that it doesn't just kind of do automatically for you, there's enough extensibility in there where you can go and tweak it and get it to do what you need to do. So for many, many years, I've been helping customers with these identity solutions. And when we go into customers, obviously, Identity Server, right, does the job of the authentication piece, and great, your users are logged into your apps. But once you've done the authentication piece, right, you know who the user is, the obvious next thing or the next problem that you run into or that your application is going to want to know is now what is that user allowed to do? And so, for a long time, customers have been happy with Identity Server, and they say, that was great, easy to put that in, get that going. You got to do the same thing for authorization too, right? Can we just put some middleware or something in my application and, you just take care of the authorization? So we've been, having customers ask us for this for a long, long time. And, we've built custom solutions for customers over the years, but we never had anything that kind of productized it, if that made sense, kind of like Identity Server productizes identity. So we've been wanting to work on this for a very long time, and we finally did, spent a lot of time last year thinking about this problem, and we worked on a commercial product called Policy Server to help out with this. Now, this talk's not really about Policy Server, it's about the sort of the conclusions and the patterns that we learned while building it in how we think you should be, or how a lot of applications probably should be modeling their authorization. And so that's pretty much what we're going to talk about. I should mention that the Policy Server is basically a combination of myself, Michelle Leroux Bustamante, who's also from Alliance, and Dominic Beyer, who's my colleague that I work on with Identity Server. And the three of us have been really, really, thinking about this problem. And so, again, this talk is basically trying to show you guys those conclusions that we came to about the right way to model authorization in our applications. So Policy Server is a product that implements this pattern, and it has a bunch of kind of standard commercial features, right? Centralization of authorization and multi-tenant support and administrative UIs for building policies, various other things, auditing, multi-tenancy, stuff like that, commercial stuff. We also built an open source reference implementation of the exact same pattern as well. So that's actually what I'm going to be showing you here is all the samples are on the open source implementation. And so you'll be able to go and take the samples and run them and get a feel for this pattern that we're promoting. So we spent last year going around to all of our customers and trying to find out for them how do you today do authorization? We're trying to kind of survey and figure out what we would need to build in to this product. And it actually turns out that you go into a company and they're actually doing it many different ways. Even within the same project, they might be doing authorization a couple different ways. So we saw all kinds of different patterns that the customers were using. Roles and permissions are very, very common. There's like the notion of access control lists or ACLs. that companies have kind of invented for their own systems. ACLs are kind of like in Windows, when you right-click a file, you get the properties, you go to the security tab, and you can, based on an individual user or group, you can add a permission like read or write or deny one. So there are lots of different ways of modeling authorization. Another example is something called XACML. So that was another something we looked at as kind of, hey, is this a good model to build this authorization product? And I think when we looked at XACML, have you guys ever used XACML? Anybody? I can actually barely see you guys, but so nobody raised their hand as far as I can tell. That shows you how popular it was, right? It really fixed the problem. What XACML was a extensible access control markup language. So this was kind of grew out of the heyday of XML, a long time ago when everyone thought XML would solve all of our problems. And the idea was, in XACML, you would model your authorization rules in this XML dialect, right? And as you can imagine, it was incredibly, verbose. The problem, I think, that we ran into, and by the way, if you haven't heard, authorization is really hard because there are these variety of ways. With XACML, they, I think, fell into the trap of trying to do too much. So when thinking about trying to build a product, we're trying to figure out what we can generalize into a product, that it can encapsulate and provide you this functionality. And there's a blurry line at which point you cross over, and now your authorization logic is really business logic, okay? And I think that's the problem that XACML sort of, the trap they fell into, is that they were trying to make you do all of the authorization in this XML dialect. And so, you would spew out this page-long XML, 30 lines of XML code to model your problem domain, your business domain of your authorization logic, okay? And I don't think I want to model, my business logic off in this weird DSL version of XML, especially when the business itself is written in whatever technology, say C#, and it might just be that much easier to write that logic in the native programming environment where the business logic is. So maybe 5 lines of C# rather than exporting a bunch of data, sending it over to this XACML system, and having it try to run this rules engine. I mean, you can kind of tell how complicated it is when actually people were building DSLs for XACML, like higher order sort of tooling to make the XML easier to write, okay? So fundamentally, that was the thing we were struggling with was what can you generalize and put into some sort of package and make, give some amount of security or authorization into an application, and there's some line at which you cross where, that's not really general authorization. Instead, that's actually the business logic of your application. So actually, that's kind of the conclusion of this talk. Thanks for coming, right? But we realized there's several different layers of authorization, and what we decided to model in the product that we built was basically using roles and permissions, right? It was kind of the common theme across pretty much every system that we saw. People understood it, and it does a good job of being sort of a generalized mechanism for modeling this. So we use roles and permissions a couple different ways because, again, authorization in a system, there are actually very many different tiers or levels of where authorization will be checked, and this could even be within a single request into your web server, right? So we've kind of realized roles are a really good kind of coarse-grained mechanism for doing authorization for maybe the entire product that your end user is trying to use, right? So one of the customers that we worked with in coming up with these, this modeling and this product is a healthcare-related company, and basically they have doctors, nurses, and patients, right? That's their roles for all the users in their system. So, there's certain types of apps where you have to be a doctor or a nurse to get in, and if you're a patient, you shouldn't get in, okay? So that's nice, easy, top-level, kind of coarse-grained, authorization logic. So we figured roles made good sense for that. Then, within the application, you might be going to different feature areas, right? Maybe a component within the software or a particular function in the software. And, you could use roles to model those, but we found permissions also are a really good model. So permissions do a decent job of kind of giving you the notion of if the user's allowed to perform some sort of action, okay? And, again, that's still kind of general. You can have an external system where you configure this roles and permissions. You map users into roles, and then roles are granted access to permissions. And that made sense. That felt good when we were building this product. But then there's the line that I talked about where you start to cross where, well, now the logic that you're talking about in terms of authorization is very business specific. And that's where we decided to stop. We said, you know what? That is, domain logic, right? About, maybe in the medical system, about prescribing medication, right? So can this user prescribe medication? Oh, to this patient, but maybe this patient actually has allergies to the medication. That feels like business logic to me, right? If you're building some medical software, that's the value of your software. That's the business that you're in. So building that logic outside of that system itself, like I said, didn't make sense to me. So like I said, this is kind of our conclusion about how authorization, at least in this generalized system we were trying to build, where it should stop and where the rest of the logic is, like I said, just your business logic. All right, we built this thing, and we're actually still working on it. And kind of at the end of building it, we said, hey, you know what we've just built? Something called ASMAN, okay? So, no, not the Fusili Jerry Seinfeld sort of ASMAN. It's a different one. Do you guys remember this tool, ASMAN? From like 10 or 15 years ago, the people with gray hair remember, right? So this was a tool that Microsoft built, and it was actually kind of a nice tool, because what it allowed you to do was define a set of roles, and you could map users into the roles. And then this tool knew about your COM components. And at the class level, the interface level, or the method level, you could then assign what roles had access or what permissions to use those functions. And this was a nice tool because hey, there was visual. Somebody could go and sort of from an administrative standpoint, not a developer, go and map users to the right roles or permissions to give them access to the functionality they needed, okay? So it's actually just kind of funny because when we were building this, we didn't really kind of think of ASMAN, but we then, in retrospect, realized, okay, that actually model worked well, and so we've kind of reinvented pretty much that. All right. So here's the general architecture that we end up having when we are, building these identity systems. And what you end up with is several different types of applications, depending on what you're trying to build. You could have server-side web applications, JavaScript, browser-based SPA-style applications, native applications, mobile apps, for example. And of course, you have users using those apps. And so what you typically do is, if you want to know who the user is, the authentication, then you go set up some sort of identity as a service, right? You set up a security token service that implements protocols like OpenID Connect and OAuth, and this gives you the benefit of single sign-on, centralized identity management, and then all the apps, they don't have to worry about authenticating, they sort of outsource it to the identity provider, and that also then protects your web APIs. That's great. So again, that's the authentication architecture. The trap that most people fall into or have fallen into that I've seen of kind of like the wrong way to go about doing authorization is that they say, I've already done all this work and effort of setting up this identity system, centralized, that's awesome. You know what? Now I need to do my authorization. Why don't I make that thing also do my authorization? Right? Somehow jam authorization information, permissions, whatever, into this identity system, and then that'll take care of both. It's security, right? Take care of both, okay? And that's very much the few customers that we ended up seeing that had gone down that path ended up being, problematic. There are several different issues that come up, and I'm going to talk about those here in a second. So this is kind of the reminder that not to do that, right? The identity system is not your authorization system, right? I mean, those semantically mean different things, okay? So it's generally a bad idea to try to overload your authentication system with permission data. Here's an example of that. So the job of your identity system, your centralized identity system, is to issue tokens. And the tokens represent the identity of the user, and these get sent around to your apps and or your APIs, and in the tokens go claims, okay? So we see a token here, this looks like a JSON Web Token, and in here are several groupings, if you will, of claims. So one grouping up here is the fact that we have some sort of protocol and authentication related claims or information. Okay, so who issued this token, right? That's needed for trust, things like that. We also have information about the user, metadata about their authentication, like when they authenticated and what they used to authenticate. They used a password. And then there's also this thing called the audience. And the audience indicates where this token is allowed to be used. Okay? So this actually looks like an access token to me. That means this is a token that we use to call APIs. And this token's job, or can be used at both maybe API 1 and API 2. Okay, great. That's totally normal what a token looks like. Of course, we'll also have information about the user, right, their identity information. So we'll have a subject identifier, that's the unique ID of the user, and then maybe other attributes about the user like their name, you know, their email, if you need that, things like that. So these other claims are where it starts to get a little blurry, okay? Sometimes I've seen people put permissions into these tokens, okay? And that's like very obvious authorization information, not identity information, right? And these permissions may be things like, oh yeah, the user can delete data and manage customers and so on and so forth, okay? So there's a bit of a problem with that, right? The problem here is this token can get used at API 1 and API 2, okay? The permission called delete data, which of those is that appropriate for, okay? Usually applications have the notion of application-specific permissions because maybe they just do different things. But now, if we're overloading this token that's meant to convey the identity of the user with permission data, now it's not clear, you know, which context that permission makes sense, okay? That's a little bit of a problem. Another type of thing we have in here are also roles. And roles are really kind of in the gray area here when you're talking about identity versus authorization or permissions, right? So the role of doctor, well, let me take a step back. When I think about roles, I kind of think roles in one of two ways. Role could be used for identity data, or it could be used to model permissions or authorization. So the role called doctor, to me, feels like identity data. So for me, I'm okay with doctor being in here, okay? But the role called approver, that sounds more like a permission to me, right? So it sounds, you know, ambiguous as to what that really means and in what context does that mean. So if you have a role, if you're using roles and they have like verbs in there, chances are you're using that as a permission or an authorization role as opposed to an identity role, okay? So again, these, because the token can be used at multiple places, it may be ambiguous if these permissions are applicable at those locations. What about if you get removed from one of these roles, or you have one of these permissions, you know, denied? What's the problem? Well, the app will still have access to these permissions, right? It can still use these because these permissions are embedded into the token. You have a copy of that data. So if you actually end up deleting in the database your role or permission or whatever, the token, you know, it's out of date. So the kind of like solution to this is kind of what Windows does, is if your, you know, domain admin adds you to a group, you have to log out and log in again, okay? So maybe that's not terribly desirable. Another problem with this is, of course, the amount of size or the number of roles or permissions that you might try to put in here, right? You could have 1,000 roles or 1,000 permissions, or probably with permissions, an infinite number of permissions. So there is a physical limit to this, you know, token size because it's being sent over the network, right? HTTP headers and whatnot. So again, the various reasons why putting permissions and roles in here are problematic. Okay? So again, this is just showing the same thing. The idea is that this token is meant to be used at multiple APIs. All right. So yeah, here's your summary of that. For authorization, what you really want to do is have the token represent the identity of the user, and then you pass that into something else to actually figure out your authorization. And that something else is some sort of permissioning system, okay? So permissions might just be like logic based on the identity, or permissions might actually be things like in a database, like flags in a database. And the thing that is needed to understand here is that this equation has to have context. in what scenario are you trying to do something, right? Is it in API 1 or API 2? Or, I can do certain things in the oncology app, but not in, the other part of the app, okay? All right, so that's fundamentally our thinking on this. Your tokens, your identity should just be identity, and permissions should be a separate thing. So our proposal is to introduce something else in your ecosystem which allows you to model these permissions. And we're calling this a policy provider of some sort. It's basically some sort of engine that knows how to take the identity as an input, as well as the context of where the identity is trying to be used, and then return to you as a result the set of roles and permissions that you're allowed to be in, okay? So here's the kind of workflow that we're thinking here. As a user logs in from the identity system, you'll of course get their identity in whatever token you have. And then as that application wants to go and determine the authorization for the user, you go and contact some sort of policy system. And again, I'm kind of hand waving here. This could be a centralized system, or it just could be a database lookup, right? Whatever you want that to be. The point is, it's separate from the identity system. It's some engine that will do some sort of mapping for the identity of the user and the context in which the user is trying to perform their operation, okay? So then based on that information, if this is like the front end, maybe the front end could then say, you don't have this permission, therefore, I'll hide or show a button or menu in the application. And then as that application calls out to other parts of your system, same thing. These all will get the context, will get the identity of the user. They each have their own context, and they will then do their own mapping for that particular system of what the roles and permissions are for the user. And then what would be really nice is on top of this, some sort of nice administrative tool where your sysadmin could go and manage this, right? Your sysadmin could go and say, hey, we have this new hire, they're a doctor, they'll put them in that appropriate role or grant them the appropriate permission. Okay, that's the idea. So this is actually what we ended up building. We ended up building this policy server product. It has internally this engine that does this mapping that's context aware based on the identity of the user and the application that they are trying to access. And then what we have are a few web APIs. One web API is a management web API. So of course you could build some sort of management tooling, management UI to go manage these policies, these mappings of users. The other thing about the API is that maybe if you built your own custom user management workflow, or you already have your own user management tools, then you could simply tap into the API to augment the underlying policy system. And then what we have is another API, which is the client API, which is what your app or API would connect to map the user into their roles and permissions. So the parameter that we pass along here is we're going to pass along the claims for the user and which application cares, which context we're in, and you'll get back these roles and policies, roles and permissions, excuse me. Okay, that's the high level idea. Now, this probably, you're like thinking this is not rocket science, right? We've probably done this yourselves or done this ourselves, but that's fundamentally the problem that we saw, is we went to our customers and saw that they had already written this and written their own version, and then some other project within the same company, they'd written their own kind of flavor of this as well. So that's the motivation behind sort of standardizing this. So from a programming model and a modeling of authorization, that's fundamentally what we have, is now this model where the user comes in, we're going to map them to roles and permissions based on the app or the context that they are accessing. So how can your application actually now tap into this? And now once you know the roles and permissions, how do you actually enforce them within the application? So there are a couple things we can do here. So I have some code to illustrate this. And first and foremost, what I have is, if your application wants to know, the roles and permissions that the user gets mapped to, then you need to have access to this engine of some sort. So what we have here, actually first is an application where I log the user in. That was actually a pretty important feature to us, is that we wanted this policy system to be decoupled from the identity system, obviously for the architectural reasons I mentioned, but we didn't want to force you to use identity server, for example. So this policy system, this programming model obviously could work for anything if you're using Azure AD or something else as well. So what I have here is just a really simple login page to model logging in the user. So, if you're typing the username Alice, then hey, you're Alice. And so what we're doing is when we log Alice in, we'll see that Alice has a unique ID of 1. That's the subject claim, sub. That's Alice's user ID, if you will. Right? Bob is going to be, I guess, user ID 11. And we have a third type of user who is user ID 21. I guess if you're not Alice or Bob, you're somebody else. And the idea, I think, is this person is going to be end up being a patient in our hospital system. So I think Alice, ultimately I'll map it to a doctor, and Bob will be mapped to a nurse. Okay, so I'll run this real quick, hit secure, log in as Alice. Great, I'm logged in. I have 2 claims, subject and name. So now this application wants to know, okay, for this application, for the, this is going to be my emergency room application, what are the user's roles and permissions? So to model that in the reference implementation that I have here, what we have is the policy provider is just in memory. And it is driven in terms of the mapping rules based on some configuration out of our JSON file. So what we have is just some really simple JSON that allows us to define what roles we are going to have for this application. So this particular application has a doctor role, and it allows me to map which subject identifier to them. Okay? And we have a nurse with some subject identifiers, and we have a patient as well. So in the way we've done the simple implementation, the reference implementation here, you can map users based on their user ID, or you can map users based on their identity roles. So remember I was saying, I made the distinction between roles being used for identity and roles being used for authorization or permissions. So the assumption here is that if the user logs in and the identity system says they're a surgeon, okay, that's fine. The centralized, Active Directory knows that Alice is a surgeon. Great. Maybe that's a group that she's in. That identity information will come to this application. This particular application, maybe it's the emergency room application, it doesn't care if you're a surgeon or an oncologist or whatever. We just want to model users in terms of these 3 roles, doctor, nurse, and patient. So the role doctor, nurse, and patient in this particular application, those are application-specific roles. Okay? And that's how the app is decided to model its authorization. So we're mapping identity data, using identity data, whether it's your unique ID or maybe your identity roles, to an application-specific role. Then, once you have these application-specific roles, we have also the ability to model permissions. So the permissions are the operations that a user might be performing in this application, and then as you can see, it's a really simple mapping. Oh, you are going to map to this application-specific role, therefore you get this application-specific permission. So how does your app at runtime now actually run the mapping? Okay? So that's the first thing that we have here, is you need some way to be able to invoke this mapping engine. And what we have is the notion of a service that can go into the dependency injection system for you to trigger that. So what I have is a policy server client interface. This will go into the DI system, so I gotta go configure that in a second. But the idea is that your page, if you're running along, you just want to know. And you can say, hey, I want to pass this user in, wherever I came from my authentication, and I want to get back the authorization results for them. And, again, it's not rocket science here. We're just returning a list of roles and permissions. Okay? So that's one way to do it. So let me go down here, go into my application, call my client. I'm going to say evaluate async, and then I'll pass in the user object that will have been populated from in this case, the cookie come into my application. And I actually will just show that then in my view. Okay? But again, the result has, like I said, the roles and the permissions. So you could simply take these 2 collections, look for the one that you need for the context that you're in this particular bit of code, and then do your allowed or denied. Okay? So for this thing to work here, I need to put it into the DI system. So I can go to my startup code, and what I have is an extension method here that will populate the policy server client. service into DI loaded from the data from my configuration file. Okay, so I run this. Assuming Visual Studio complies. And it's not. You guys seen that new feature in Visual Studio? The one where it locks all your files and then you can't actually rerun? Yeah, you gotta wait, hit no, and then start again. Okay, now it worked. So again, I think I'm logged in as Alice, user ID 1. If I go to my secure page, yeah, look at that. So what we're now doing is this is the data, the claims that are coming from your cookie. We take those and we invoke the policy server engine, and we get back our app-specific roles and permissions. Okay? Real simple, right? Okay. So that's one way to tap into the policy system, is you just call it, you get back these two lists, and then your application logic, does whatever it needs to based on that. Okay? Another very common pattern, though, that people would like, so this is a different way to react or have your application respond to the authorization information, is we can use the good old authorize attribute. Okay? So the authorize attribute, right, with roles equals, people use this all the time, right? This is kind of your coarse-grained role-based authorization. So how do we do that? Well, for this to work, this authorize attribute is calling the isInRole method for the current user in the application, right? Well, does my current user have a claim for the role? No, right? The code down here, this is just showing what came back from the mapping, right? But for the isInRole check to work, my claims off of the current user object have to have a role. So what I kind of need to do is take the results of this and populate the claims on the current user for the current request. Okay? So if you guys were in my workshop the other day, we talked about the concept of claims transformation. Right? The cookie only has a couple claims. You're now running the policy engine, mapping those to a bunch of new claims and merging them together. And then for the duration of this request, you have them all kind of in one place. So for this to work, we need some sort of claims transformation. And that's another little widget we've added here into our little library. Okay? So what we can do is do a use policy server claims transformation, and it will go off and do that mapping. So if I rerun this now, we should see then on the secure page, yeah, look at this. So now we have the original two claims that came from the cookie, and what we're doing is we're running the policy engine, mapping to roles and permissions, and then we're actually creating a new identity and merging it into the principal. If you guys are familiar with the identity and principal interfaces and the claims identity and claims principal, that a principal is the user object. It can have multiple identities. So we're just putting in two different identities, one from the original cookie and a new one that we created coming from this claims transformation. So now that we do have a role of doctor, I probably should have done this a second ago. I should be able to go into my app and now do the, nurses only action, for example. Okay? And I don't want to leave that uncommented. Okay. Cool. So now I should be able to do the nurses only action. And actually, because I'm a doctor right now, I don't think this will work. Yeah, exactly. We got access denied. But if we log out, log back in as, say, Bob. Okay, Bob, different identity. Bob has different set of roles and permissions. Then, great, that one works. Okay? So that's just a different way to capitalize upon this mapping layer, this abstraction that we're setting up to map a user to roles and permissions specific to this application. Another approach for utilizing the authorization is to actually tap into something more sophisticated. So ASP.NET Core has a brand new authorization system, and unfortunately, it's called the policy-based authorization system. So we now have the term being used in two contexts here, so my apologies for the confusion. As we all know, naming's hard. So the idea is that the mapping layer that we have in the JSON file, that's the policy server feature. And what we want to do then is take the results of those policies, the roles and permissions, and run it against this more sophisticated policy-based authorization. What makes the policy-based authorization system a little bit more appealing than the role-based is that it gives you a level of indirection. It gives you a place to put some code that has your rules if the user's allowed or denied, and you put that in a centralized place. Rather than you putting nurse and doctor, and then, oh, I also have to put the nurse and doctor string into the UI and any other place I need to run this rule, you're duplicating that sort of logic here. The policy-based system from ASP.NET Core allows you to build your logic by defining what's called a policy, right? And so what we can do is we can build a policy, in this case, prescribed medication, and what I want this policy to do is first check to see if the user is authenticated, right? You shouldn't be prescribing medication if we don't know who you are. And then second of all, we're now depending on a claim that was produced by the user mapping layer, right? So that's the policy server JSON mapping that I talked about, okay? So we're merging an ASP.NET Core policy with the results of the policy server mapping. So I can build this policy, and then the beauty here is that down on the bottom right, if you can see that, is that the authorize attribute allows you to just put the name of the ASP.NET Core policy, and it will basically give you that level of indirection to run that authorization. So I think I have this code somewhere in here. Yeah, here we go. So I have a perform surgery, let's call it, well, I'll just leave it there. So perform surgery ASP.NET Core policy, and it is triggered off of the perform surgery mapping that had come from my, my policies here in the JSON file. Okay? So now that I have a perform surgery, I can go back to my home controller, and here we go. We have another action method that presumably I think only doctors can do. Okay? All right. So if I run this, secure, let's see, let's do Bob first. Okay, if I scroll down, Bob should not be able to perform surgery. Okay, makes sense. Come back in, Alice. All right, and Alice should be good to go. There we go. Okay? All right, so that's just a quick look at the ASP.NET Core policy system. Like I said, it's kind of nice. You have a nice little place to put your logic about the user, centralized one place, and then you can just reference it from your application code. Another way to reference this from the application code is obviously we can use the authorize attribute. One of the complaints though is that the authorize attribute doesn't help you with unit testing. So if this code right here needs to be unit testable, you need to, it would be nice to be to go in and write your unit test and pick up this logic. So one more thing you can do, actually I won't bother writing the code, it's in the slides, is that you can actually inject a service called the authorization service. This is coming from ASP.NET Core, and this ASP.NET Core service, authorization service, allows you to programmatically check with this authorize call. And you can say authorize the user, and you say the name of the policy. Okay, so again, the string on the right there, prescribed medication, is basically then finding the policy up in the top left, which is then checking a permission, which we mapped from our JSON file. Okay? The nice thing about now that you can do this programmatically is that you could also then not only enforce your authorization logic at the action method that's really performing the action, but you can also then leverage this other places in your application, and the UI is probably a good obvious choice here because if the user's not allowed to perform the action, why don't we hide the button in the first place, okay, or the menu? So this particular style of doing this is, debatable whether or not it's the best way, but this is you can do dependency injection in your Razor views, right? So you can inject the exact same interface I just showed you, or probably if you were really trying to do this in a cleaner way, you would inject this still into your controller, and then when you're building up your view model, just have a flag that says to the Razor page whether the button should be, shown or hidden. Okay. So what I've shown you is kind of a nice little, combining of the two patterns, the policy server mapping engine to give you roles and permissions, and then tapping into the ASP.NET Core policy system to get the benefit of using the attribute or using the authorization service. Okay? The only downside about doing it this way is I think in my JSON file, I had like 4 or 5 permissions, but for anything real, right, you could probably imagine 20 or more permissions. And I don't want to have to come in here and define a policy in the ASP.NET Core policy system for every one of my permissions that's, in my permission system. So it turns out that the authorization system itself from Microsoft is extensible. They actually have a policy provider, I think is the name of it. And what happens is at runtime, whenever your application, like for example, down here, when we trigger the ASP.NET Core policy with that string, in this case perform surgery, what happens is the ASP.NET Core system goes and looks for the service and DI that will find the policy. And by default, it finds the policies based on the static mapping I've done here. Well, that interface, that policy provider itself is replaceable in the DI system. So what you can do is instead of using the built-in policy definitions, you can implement it yourself. Or you can leverage the one that we've done that will implement it for you. So what we have is off of our DI system where we configure the fact that we want to use policy server. We then have a little authorization permission policy. So this registers our custom policy provider. And now our custom policy provider, what happens is when the policy is being requested, okay, we go and basically look for the matching permission name from the claims, okay? And also we do this not by looking at the user claims, the in-memory user claims. Instead, we do this by actually calling directly into the policy server client interface, which is the same one I showed you here that you could call directly. What that basically means is that it's actually calling, if this is still running, I don't think it is, that means I don't need to do the claims transformation anymore, okay? So actually for this to work, I can even take the claims transformation out. Okay, so I'm just showing you different styles about how you can, actually enforce this authorization. So, maybe one you want to trigger off the user, the other you want to do this policy system. So if I ran that correctly, just double check that I didn't miss anything. So I took out the claims transformation, I wired up the policy provider, and now I got rid of the one I statically did the mapping for. I come back in here, and I'm still Alice, so I should still be able to perform surgery. Yep, and again, checking Bob here. Yeah, good. All right. Okay, one last idea, one last technique, I suppose, for tapping into the ASP.NET Core policy system is they actually provide a mechanism for being a little bit more sophisticated with your ASP.NET Core policies. So let me go back here. So this policy that we defined in the top left, this ASP.NET Core policy, the main input into the logic is the user. So the logic only is looking at what claims the user has to decide if you are allowed or denied to prescribe medication. That may be fine for some logic, but in other scenarios, you might actually need more information, okay? So what ASP.NET Core provides is the ability to create what's called a custom requirement. And a custom requirement allows you to model additional data that is an input into your authorization logic. So in this case, we have an example of a medication requirement. And so this is where what we want to do is, we said, oh, maybe nurses or doctors can prescribe medication, but maybe depending on the type of medication and the amount of medication, that's not good enough, okay? So maybe for, aspirin or something, a nurse can prescribe that, but for morphine, the doctor has to prescribe it, something like that, okay? So ASP.NET Core actually has a way to do this. You create this class called a requirement. It models your dynamic data that needs to be this input into the authorization. You create what's called a handler, and this handler is an authorization handler of your custom requirement class that's up here in the top right. And then there's a method in the middle here that you have to implement called handle requirement async, okay? And what gets handed into this method is the user, and then that requirement object. And that requirement object is what has the medication and the amount. So now you have the user and that additional data, and you can go run whatever logic you want to. So now this is actually an interesting combination of, we're kind of getting on the borderline of using the role and permission mapping from the JSON file, but then sprinkling in some additional application logic here. We're kind of mixing the two, okay? So in this case, I don't know, what do we have here? If you have the permission to prescribe the medication, great. And it's a low amount, fine, you're good. But if it's a high amount, you need to be, in this case, a doctor, for example, okay? And I guess if the medication is a placebo, then yeah, sure, you can prescribe that too, okay? So that's the idea. Now, the way this actually gets triggered in the application is, one, this class has to go into the dependency injection system, okay? So this goes into the DI system, and then from your application, you can only trigger these programmatically, right? You can't use the declarative authorized attribute because you need to create the requirements object on the fly. So you would, in your action method where we're prescribing medication, create the requirement object, call into the authorize method. If it comes back and says you're good to go, the method succeeds. If not, you tell the user to go away, okay? And you can either use challenge or forbid. Those are the two built-in methods in ASP.NET Core. So that's an example of kind of mixing the two styles, if you will. Okay? I think what's really interesting about this is that if you notice how we actually implemented this, how did I know if you could just do the kind of the coarse-grained prescribed medication check? Well, if you look, because this class is in the DI system, it itself can take dependencies on other services from the DI system. So you could actually take a dependency on the policy server client interface and call into it to do the mapping. Or, again, you may even have other stuff in the database, right? Other flags, permissions, columns in the database that have, you know, yeses and nos, and says whether or not the user is allowed to. So, kind of an interesting mix of the two. Any more than this, though, I mean, even this, I'm actually a little on the fence about, personally. Because now we're really starting to blend some business logic in here. And this is where, like I said, that we decided deliberately with Policy Server to stop. We realized that, you know, would it make sense to externalize this type of logic? Would it make sense to take this type of logic and go put it in some other system in some XML file that had these rules? Yeah, I don't know, because then what would have to happen is if at runtime, when you're invoking the business logic to prescribe medication, then you have to take all the data of the context, not only the user, but now the amount and the medication and maybe even some more data out of your database, export all of that to this other system and have it run the logic to produce a yes or a no, okay? And that's why we thought that in building a product or building any kind of framework to satisfy this pattern, I think there's a point at which the framework can generalize only so much, and anything beyond that is probably a mistake. And it makes more sense to put that kind of logic, like I said, right here in your business code. Okay. One last thing just to mention, a very common pattern that I think tends to be a nice thing to do is making sure that if the user's not authenticated at all, they're not allowed to get into your application. So in MVC, in ASP.NET Core, you can set up a global policy, ASP.NET Core policy, where you basically require that the user be logged in. When you build that policy, you could add any additional requirements on the user, such as being in a particular role. So this is another good example of where, you know, for the coarse-grained check, like do you have access to the app or not? Maybe only in the emergency room software the doctor and the nurse should be accessing it. So you can set up a global authorization policy for ASP.NET MVC Core. It's a little weird how you do it, unfortunately, but you have to build this builder in your MVC options when you're loading up MVC in the DI system. And you pop in your requirements there, and then you set that up as a global authorized filter. Still, I think this is generally a good practice to put in. So, like I said, we've kind of already talked about the conclusion here, but this is basically the conclusion that we had, is that for coarse-grained type of logic, roles make a lot of sense. For feature access within an application, roles or permissions, combination of the two, make a lot of sense to externalize into some, helper library to help you out. But beyond that, it really starts to feel forced to try to have an external system incorporate whatever your business logic might be. Okay? So that's the conclusion we came to. And that pretty much is sort of the mental progression that we went through when building Policy Server. There are a couple of resources here. My colleague Dominic has a blog post that kind of talks about the background of this. There's some more information about the ASP.NET Core authorization system. And there is the link to the GitHub repo for the sample code that I just showed you. I think we have a few minutes left. If there are any questions? Yeah, question.
The example you just talked about the business logic being separate, makes sense. No, the problem we have is the administration part of it. So if we want to add it there, so you have to go to one system, and then the administration has to do something else.
Right. So I think the comment is about administration of this. So if you really are using different components for your authorization, that feels scattered. Okay? Well, if you build an administrative UI to aggregate all that together, then from the end user's perspective, it won't seem scattered. We do that all the time, and that's one of the reasons why in the product that we built, our management piece has an API, so that you can then call that. So your aggregated UI can call one system for one type of thing and one type of, another system for another type of thing. Again, I think that's the nature of the beast, right? Because authorization, like I said, is done at many tiers. Even within a single request into a web server, there's lots of different stages where different authorization might need to run. And it's different, like, scope, if that makes sense. Okay? Yeah. I can just show you real quickly the Policy Server product, kind of the thinking behind it. Here is the admin UI that we have for managing policies in the Policy Server product. And this is the pattern is exactly the same I just described. The idea is that we are going to have policies, and you can then, for a policy, you typically use a policy to model an application's authorization requirements. So here's the exact emergency room sample that we had from before. And you can come in here and define roles and permissions. And when you define roles and permissions, you can come in here and say, what identities map to this particular application-specific role. And then based on that application-specific role, you then map which app roles can access various permissions. So it's pretty much the same thing I just showed you. This is just centralized in a database. There's an API behind this management UI. That API is the same one that you could call from your aggregated UI if you wanted. And there are auditing features as well on this, as well as multi-tenancy support. You may have two different tenants with different sets of users that you want to obviously map differently. Another interesting feature we have, though, is the ability to build a hierarchy of policies. So it might be very common that you have a couple different applications that actually have shared roles. So the idea is that when we built this, we needed to be able to support that. So you can define a policy, and at the root policy, you define the shared roles. All your applications in the hospital system have these roles and these users mapped to it. Okay? But at the top level, you don't really have any permissions because what's being modeled is the hospital, not any one app. And so then what we can do is create a child policy underneath it, and the child policy is what actually models the application. It, by virtue of being a child policy, you inherit all the role mappings, but then it's at the child policy where you define your permissions and do your assignments of roles to these features. Okay, so it was, like I said, an important feature to implement. And once we realized that these policies have this hierarchy and that the nodes in the hierarchy don't have to model an application, it can be really model whatever you want it to. So we took this one step further and started prototyping and saying, hey, what if the actual policy is modeling a resource in your system? So let's say you have a medical records system and you have rules about which roles can do which permissions to operations on medical records. And then you actually create a policy in here to represent an instance of a medical record in this system. And at this particular instance, you then map particular users into roles. Then you have the ability to have two different medical records with two different users having different levels of permission, for example. Okay? So that's kind of an interesting feature here. Now, the interesting thing is when the application connects, when it invokes the policy, it has to pass a path to the policy. So the users in the app, they're trying to access policy, 1, 2, 3, and so the app will connect and say, hey, I need to execute under the hospital system, the medical records app, what are the permissions for this user for, record 1, 2, 3, for example. Anyway, just a little bit of thinking behind the commercial product and what that offers beyond just what I showed you here in the really simple, role and permission mapping. Okay? Yes, question?
Does that view that you were just looking at there, does it have any provision to manage the roles for an individual user?
So, so the way I think about this is that roles, and there's an exception to this, but roles generally are owned by the application, right? In my emergency room software knows about the roles because it knows the types of users, doctor, nurse, and patient. It also owns the permissions, okay? Right? Because it's implementing these features, right? When you go in to then manage, what you're doing is you're mapping users onto the roles, okay? And we have multi-tenancy support. So if I'm the manager or the admin of tenant 1, I'm only going to map my users to these roles. And if I'm the admin of tenant 2, map different, my tenant 2 users to those roles. You might also want to create a grouping of users for that tenant. So instead of mapping one by one, you create your own grouping and assign. That's also possible. That's also done with a role, but it's a tenant-specific role as opposed to an application-specific role. Anyway, that's detail. So that's how the mapping happens. So I'm kind of missing your question.
I guess, if I wanted to look at user X.
Oh, and see everything that they're, yes. Yeah, so actually I should mention, the UI we're showing you, we have a couple different, versions of the product. We have the basic version and we have the enterprise version. This is just the basic version. The back end is all implemented for that kind of slicing and dicing of queries. The enterprise version of our UI is just not done yet. Okay? Yeah. Okay, so that's basically, like I said, our conclusion on how authorization, could be done. It's definitely a challenge and a complicated process or a requirement to meet. But the idea behind kind of generalizing it and building something out of it is so that, everybody doesn't have to reinvent this wheel, over and over. Okay? All right, well, thank you. Have a good party tonight, right? Is there a party tonight? Yeah, okay.